Okay, so we are going to talk about squaring trigonometric equations in order to find some solutions. So sometimes the only way to solve is to square both sides and use some identities. Okay, so if I have cosine x plus 1 equal to sine of x, there's no relationship there that's going to help me solve, and I can't really solve with two different things. So one thing I can do is I can square both sides. And I know that sine squared x is going to equal 1 minus cosine squared x. So if I can square the sine of x, then I can get my cosines all together. So this becomes 1 minus cosine squared x. This right here is a binomial square, so that will be like cosine x plus 1 times cosine x plus 1. That's a cosine squared x. Then I have a 1 cosine x, so 1 cosine x to be a 2 cosine x, and then 1 times 1 is 1. So the left side will become cosine squared x plus 2 cosine x plus 1. And now I have everything in terms of cosine. So I'm going to, once again, solve it. So I want everything to one side set equal to 0. So I'll subtract the 1, and I will add a cosine squared x so that this side zeroes out. That gives me a 2 cosine squared x plus 2 cosine of x equal to 0. Okay, the next is to ask yourself, is there a greatest common factor? And in fact, there is. 2 cosine x is a part of both of those terms. So I'm going to take out 2 cosine of x, and I'm left with cosine of x plus 1. Okay, so the next thing I want to do is set each equation, each of these factors equal to 0, like we did the other day. And this will be a 2 cosine of x equal to 0. Divide by 2, and cosine of x is equal to 0. This one will be cosine of x is equal to 1. Okay, so my solutions from 0 to 2 pi would be, when cosine is 0, that's at pi over 2, 3 pi over 2, and at cosine being positive 1, that's just going to be at 0. Those are my solutions in the interval from 0 to 2 pi. Okay, here's another one. I have sine of x plus 1 equals cosine of x. Again, I have a sine, I have a cosine, they're both to a power of 1, and the only way that I'm going to be able to really solve this is to square both sides of the equation. And I know that cosine squared x is equal to 1 minus sine squared x. So this right here is going to become 1 minus sine squared x. And sine of x plus 1 squared is 2 sine of x plus 1's being multiplied together, which gives me a sine squared x plus a 2 sine of x plus a 1. Again, bring everything to the left side, subtract 1, that zeroes out, add sine of x squared. This whole side becomes 0. Alright, that gives me a 2 sine squared x plus a 2 sine of x is equal to 0. Factor out the 2 sine of x. I'm left with sine x plus 1. And then this right here, when I set it equal to 0, I'm going to get the sine of x equal to 0. The 2 will divide out, and this will give me a sine of x equal to a negative 1. So again, I need solutions between 0 and 2 pi. When is sine 0? It's 0 at 0 and pi. When is sine negative 1? That's at 3 pi over 2. So these are my solutions. Now, the big question is to go back in and test these solutions. Okay, so the cosine of something plus 1 is supposed to equal the sine of something. So cosine of pi over 2, let's just plug in, let's just start with 0. Plug in a 0. The cosine of 0 is 1, right? Okay, so 1 plus 1 is 2. And 2, what is the sine of 0? Well, that's 0. So that is not equal. So 0 is actually not a solution. Okay, so then let's go back and test the other solutions. Okay, let's try pi over 2. The cosine of pi over 2 is 0, and 0 plus 1 is 1. The sine of pi over 2 is 1, so that works. 3 pi over 2. The cosine of 3 pi over 2 is 0, and 0 plus 1 is 1. The sine of 3 pi over 2 is negative 1, so that is not equal. So my only real solution here is pi over 2. We need to check those solutions. Same thing down here. Sine of some angle plus 1 is equal to the cosine of some angle. All right, so I'm going to start with 0. Sine of 0 is going to be 0. 0 plus 1 is 1. Cosine of 0 is 1. So that works. Okay, so let's erase and check pi. Sine of pi. Sine of pi is 0, right? 0 plus 1 is 1. Cosine of pi is negative 1, so these are not equal. Okay, so then we have 3 pi over 2. Sine of 3 pi over 2 is a negative 1. Negative 1 plus 1 is 0. Cosine of 3 pi over 2 is actually 0, so that's also a solution. Okay, so we do have to check our solutions there and make sure that they work. So in this example, pi did not work. Okay, let's do one more example for this section here. I have that secant of x plus 1 equals tangent of x. And again, I need them squared because I know that tangent squared x is going to be secant squared x minus 1. Okay, and then secant of x plus 1 times secant of x plus 1 is going to be secant squared x plus 2 secant x plus 1. Okay, I'm going to subtract secant squared x to 0 out here, and then I'm going to add 1. Okay, that's actually going to 0 out. I'm left with 2 secant of x plus 2 equals 0. If I go ahead and subtract the 2, I end up with 2 secant of x equals negative 2, divide by 2, and secant of x is equal to negative 1. If secant of x is equal to negative 1, then cosine of x is also equal to negative 1. And so what angle will work for cosine of x being negative 1? That's pi. So then we come over here and we have to check it. Secant of pi plus 1, does it equal the tangent of pi? Okay, so the secant of pi is going to be negative 1. Negative 1 plus 1 is 0. What is the tangent of pi? 0. So it does work.